Hi friends, welcome to Think Maths. We are in class 10 Maths, chapter 5, Arithmetic Progressions. In this session, we are going to discuss about examples 3 to 10. So, example 3, find the 10th term of the arithmetic progression. So, they gave an arithmetic progression, we have to find the 10th term. So, in all this example, we are going to use the formula an equal to a plus n minus 1 into d. So, here for a is the first term and d is the common difference. So, n is the term. Which term? So, what is given here? Arithmetic progression is 2, 7, 12, etc. So, they are asking about A10. What is given here? First term. A is equal to 2 and D is the common difference. So, it is nothing but second term minus first term or third term minus second term. So, we can take A2 minus A1 for all these AP. So, A2 is 7 minus 2 which is 5. Now, applying n is equal to 10 in this formula, we get A10 equal to A is 2 plus n is equal to 10 minus 1 into d. D is 5. So, which is equal to 2 plus 10 minus 1 is 9. 9 into 5. So, 2 plus 9 into 5 is 45. So, 2 plus 45 is 47. So, 10th term is 47. Okay, so this is an easy problem. I hope you can understand. So, let me go to the next example. Example 4. Which term of the AP 21, 18, 15, etc. is minus 81? Also, is any term 0? Give reason for your answer. We have to find for which n minus 81 appears in this AP. Also, we have to check whether 0 is present in this AP or not. So, and then you have to give the reason. So, first let us check for which n minus 81 is present. So, the AP is 21, 18, 15, etc. So, your first term is 21. D is equal to second term minus first term. So, 18 minus 21 minus is for the bigger number. So, we will get negative sign. So, 21 minus 18 is 3. Okay. Next, an equal to minus 81. So, for this, what is the value of n? We know an equal to a plus n minus 1 into d. So, what is a in here? Minus 81. A is 21 plus n we don't know. N minus 1 into d is minus 3. So, minus 81 will be here. 21 plus into minus. So, it will be minus 3 into n, 3n. So, next one, plus into minus is minus, minus into minus is plus, 1 into 3, 3. So, 21 plus 3 is 24 minus 3n. Here, minus 81 is present. So, I am taking minus 3n to the opposite side. So, it will change the sign to positive. Minus 3n will become plus 3n. We have 24 here. If I change minus 81 to this side, it will become plus 81. So, 3n will be equal to 4 plus 1, 5, 2 plus 8, 5. So, it is 105. So, then n will be equal to 105. So, 3 is in product. When the side changes, it will be in division. So, 105 divided by 3 is 10 goes 3 times. 3 3s are 9. Balance is 1. So, it is 50. So, it means 35th term is minus 81. So, what is the next question? Also, is any term 0? So, we have to check whether 0 is present in this term or not. So, let us assume it is present. An equal to 0. So, what is an? An is nothing but a plus n minus 1 into d. So, an is 0. We know a is equal to 21. N minus 1 into d is minus 3. So, it is 21. plus n into minus 3. So plus into minus is minus, 3 into n is 3n. Here plus into minus, minus, minus into minus, plus. So plus 3. So it is 24 minus 3n. So I am taking minus 3n to left hand side. It will become 3n. 3n equal to 24. So if 3n is equal to 24, then n will be equal to 24 divided. So because 3 is in product, so 24 divided by 3, which is equal to 8. So we got n is equal to 8. It means 8th term is 0. That means 0 is one of the number in this arithmetic progression. So we can say 0 is one of the term in this arithmetic progression. Give reason means here n should be a counting number. So n should not be in fractions or decimals. So if it is in fraction or decimal, we cannot count. So we will count as this is the first term, second term, third term. So if it is 1 by 2, we cannot count it as half term. So it should be a natural number, that is counting number. If n is a counting number, then the term will be present. Okay. So the 0 is present in this arithmetic progression. Okay. Next one. Determine the AP whose third term is 5 and the seventh term is 9. So if you need to find AP, so we need first term and common difference. So here they gave A3 is equal to 5 and A7 equal to 9. So we can use the general formula A plus n minus 1 into D. So n is equal to 3. So if you apply n is equal to 3 here, A3 will be equal to A plus 3 minus 1 into D. So A3 is given as 5. So 5 equal to A plus 3 minus 1, 2. 2D. So this is one equation. We can write it as A plus 2D is equal to 5. So this is first equation. Okay. This is A. So again they gave seventh term equal to 9. So if you apply n is equal to 7 in A, then we get A7 equal to A plus 7 minus 1 into D. A7 is given as 9. 9 equal to A plus 7 minus 1, it is 6D. So we can write it as A plus 6D is equal to 9. So this is second equation. So we have to solve 1 and 2 and get the value of A and D. So how we can solve? Here you can use the elimination method. So coefficient of A is same. So if you subtract, A will be eliminated. So A plus 2D is equal to 5. Second equation is A plus 6D is equal to 9. So I am subtracting. So when you subtract, the signs will change. So minus, this plus will become minus. Here also positive sign, it will become negative. So A minus A gets cancelled. 2D minus 6D. So we have to subtract and put the sign of the bigger number. Bigger number sign is negative. So if you subtract 6 and 2, you will get 4. 4D is equal to here 5 minus 9. So this bigger number has negative. So we have to subtract. 9 minus 5, it is 4. So both the negatives gets cancelled. So D will be equal to 4 divided by 4. Otherwise you can write it as minus 4 divided by minus 4. So at this step also negative sign will be cancelled. So 4 divided by 4 will be equal to 1. So we got D is equal to 1. So then we can substitute D is equal to 1 in any equation. I am going to substitute in the first equation. So the first equation is A plus 2D. D is 1 equal to 5. So A plus 2 equal to 5. Then A will be equal to 5 minus 2. Plus 2 will become minus 2 when the side changes. Then A will be equal to 3. So we got A and D. A is 3 and D is 1. So a is equal to 3 means first term is 3. So next term will be, we have to add 1 to previous term. So because d is equal to 1. So 3 plus 1 is 4. So next term will be 4 plus 1, which is 5. Next term will be 5 plus 1, which is 6. So this is the arithmetic progression, that is 3, 4, 5, 6 is the arithmetic progression. So I hope you can understand this problem. If you have any doubts, you can comment me. So let me go to the next problem. Check whether 301 is a term of the list of numbers. Already in fourth example, we checked whether 0 is present or not. In the same way, we have to check whether 301 is a term in this list. First, we have to check whether this is an AP or not. So it is given as 5, 11, 17, 23. Because they did not give the word, it is an AP. So we have to check. Here A is equal to, first term is equal to 5, which is A1, A2. Second term is 11. Third term is 17. Fourth term is 23. What is D? D is nothing but A2 minus A1. A2 is 11 minus 5. 11 minus 5 is 6. A3 minus A2 is 17 minus 11, which is also 6. A4 minus A3, it is 23 minus 17, which is also 6. So the given list 5, 11, 17, 23 is an AP. Now we have to check whether 301 is a term. Suppose if it is a term, let us assume let an equal to 301. Then we should get n as a natural number or counting number. So we know an equal to a plus n minus 1 into d. What is an? 301. A is the first term, which is 5 plus n minus 1 into d is 6. So it will be 5 plus n into 6, 6n plus into minus is minus 1 into 6, 6. So 5 minus 6 is, here 6 has the negative sign. So the answer will be negative because 6 is bigger. So 5 and 6 difference is 1 plus 6n. So I am keeping this 6n here because 6n is positive. So I'm not going to change the sign. I'm going to change the side of this number because it is in negative. So when I take this to left hand side, it will become plus 1. So 302 is equal to 6n. You can write this as 6n equal to 302. So n is equal to 302 divided by 6. Let us check whether this is divisible by 6 or not. So if I take 3, it is not divisible. Shall I take 30? So 5, 6 are 30 and balance is 2. So we get it as fraction. So if I divide by 2, this will be 151 divided by 3. 151 divided by 3 is not divisible by 3. So as it is a fraction, or we can say it is a rational number, so we cannot say that 301 is a term of the list. So 301 is not a term. 301 is not a term of the list. Okay, because we didn't get n as a counting number or natural number. We got it as fraction. So this is not a term of this list. Okay. Next one, example 7. How many 2-digit numbers are divisible by 3? So we have to find the numbers, 2-digit numbers that are divisible by 3. You know the table for 3. 3, 6, 9, 12. So the first 2-digit number divisible by 3 is 12. So next it will be 15, 18 and it goes on like this. So what is the last two-digit number? Last two-digit number is 99 and 99 is divisible by 3. So last number is 99. So we know the last number. So from this AP we know A is equal to 12 and D is equal to 15 minus 12, it is 3. So and last number is 99. So the formula L is equal to A plus N minus 1 into D. So if you know the last term, you can write instead of A N, L. So we know L, we know A, we know D. So except N, we know everything. So if you substitute in this, we can find the missing term N. It gives how many two-digit numbers. Okay. So it is 99 equal to 12 plus n minus 1 into 3. So 99 equal to 12 plus 3 into n, it is 3n, minus 1 into 3, it is minus 3. 12 minus 3 is 9. So 9 plus 3n. So I am going to keep the positive 3n here and I am going to take the constant value 9 to the other side. So plus 9 will become minus 9. So 99 minus 9 is 90 equal to 3n. So this can be written as 3n equal to 90. Both are same. Then n will be equal to 90 as it is in product. When the side changes, it will be in division. So 90 divided by 3 is 30. So 30 numbers are divisible. That is 30 two-digit numbers are divisible by 3. Okay. I hope you can understand this problem. So let me go to the next example. Example 8. Find the 11th term from the last term of the AP. So this type of problem has two methods. So first I will take the reverse procedure. So what is AP here? It is 10, 7, 4, minus 62. So here we have to check the last term. That is, we have to check the 11th term from the last term. So instead of checking from the last term, I am going to reverse this AP. So minus 62 will be the first term. Here what is D for this? D is 7 minus 10. It is minus 3. So when I reverse, D will be equal to positive 3. Minus sign will change to positive. Plus sign will change to negative. So here it is negative. So while reversing, D will be 3. So minus 62 plus 3 is minus 59. I'm sorry. Minus 59. So it goes on like this and the last term will be 4, 7, 10. Okay. So this is all given. So just I have reversed this AP. Now here what is given? 11th term from the last term. So we can count from the first term because I have just reversed. Last term became first term. So we can count 1, 2, 3, 4, 5. So we have to find A11 for this. Okay. So here A is equal to minus 62 and D is equal to minus 59 minus minus 62. So it is minus 59 plus 62 because minus into minus is plus. So 62 minus 59 is 3. So we know an equal to a plus n minus 1 into d. So we should find a11. So a11 equal to minus 62 plus 11 minus 1 into 3. So it is minus 62. 11 minus 1, it is 10 into 3. So A11 will be minus 62 plus 10 into 3, 30. So here negative is for bigger number. So we have negative sign and subtract. So 62 minus 30 is 32. So A11 equal to minus 32. So this method can be done in another way. So this is first method by reversing. So method 2, we have to use the given AP. So it is 10, 7, 4 minus 62. So here A is equal to the first term 10, D is equal to 7 minus 10 equal to minus 3. Here L is equal to the last term minus 62. For this we have to find how many terms are there. From there we have to find the 11th term. So we know L is equal to A plus N minus 1 into D. What is A? It is 10. 10 plus N minus 1 into D is minus 3. And L is equal to minus 62. So minus 62 equal to 10 plus, you will not get plus here, because plus into minus is minus. So minus 3n plus into minus is minus, minus into minus is plus. So plus 3. So minus 62 equal to 10 plus 3, it is 13 minus 3n. So here n has the negative coefficient. So I am going to take minus 3n here. So it will become plus 3n equal to 13 minus 62 will become plus 62. So 3n will be equal to, if you add this 3 plus 2 it is 5, 6 plus 1 it is 7. So n will be equal to 75 divided by 3. So it is 2 3s are 6, balance is 1, it is 25. So there are 25 terms in this list. So if you want 11th term from the last term, we should subtract 25 minus 11 and add 1 to it. So this is the logic to find the 11th term from the last term. Okay, so it will be 25 minus 11 is 14 plus 1, which is equal to 15. So we need to find what is A15. Okay, so A15 will be equal to A plus 15 minus 1 into D. So which is equal to, what is A here? A is equal to 10 plus 15 minus 1 is 14. What is D? D is minus 3. So which is equal to 10 plus into minus is minus. 14 into 3, 4 3s are 12. Balance 1, 1 into 3, 3, 3 plus 1, 4. So we have to subtract, and the negative sign is for bigger number. So we will get the negative. So 42 minus 10 is 32. So in the same way, we can get the answer. So this is just a reversing. If you reverse the AP and find as usual 11th term. Okay. So here what changes will be done? If for the given AP, D is equal to minus 3. If you reverse the AP, D will be plus 3. Okay, the signs will change for D. Then the procedure is same. So if you follow this method, if the given AP, then we have to find how many terms are there. From there, you have to find which term we need to find. So for that, you have to subtract from the number of terms minus 11th term and add 1 to it. So that will be the 11th term from the last term. Okay. So from the last term, from the 25th term, 11th term is 15. So A15 we need to find, which is minus 32. Okay. I hope you can understand both the methods. Whichever you feel easy, you can do it. Okay. Example 9. A sum of rupees 1000 is invested at 8% simple interest per year. Calculate the interest at the end of each year. So do this interest form an AP? If so, find the interest at the end of 30 years making use of this fact. Okay. So here what is given? Rupees 10,000 is invested. The bank gives 8% simple interest. So we know the simple interest formula is simple interest equal to PNR by 100. So here P is the principal amount, N is the number of years, and R is the rate of interest. So here P is equal to 1000. So N takes the value 1, 2, 3, 4, etc. And R is equal to 8 percentage. So we have to substitute these values and find out what is the interest for each year. So interest for first year equal to, what is P? It is 1000. N is the first year, it is 1. R is equal to 8 divided by 100. So which is, these two zeros gets cancelled. 10 into 1, 10. 10 into 8, 80. So it is 80 rupees. So interest for second year. So what will be the interest for second year? 1000 into 2 into 8 divided by 100. So these two zeros gets cancelled. 10 into 2, 20. 20 into 8, it is 160. Next, interest for third year. It will be 1000 into 3 into 8 divided by 100. Both the zeros gets cancelled. So it will be 10 into 3, 30. 30 into 8, it is 240. Rupees 240. So it goes on like this. So the list is 80, 160, 240, etc. So here A is, the first term is 80. D is equal to 160 minus 80, which is 80. Also 240 minus 160, it is also 80. So the difference is, common difference is same. So we can say that this interest form an AP. So if it forms an AP, we can use the formula AN equal to A plus N minus 1 into D. So what they are asking? They are asking interest at the end of 30 years. So here N is equal to 30. So A 30 equal to, what is A? A is 80 plus N is 30 minus 1 into D. D is 80. So 80 plus 30 into 30 minus 1, it is 29 into 80. So 80 plus, what is 29 into 80? So you can put this 0. 8 nines are 72. Balance is 7. 2 eights are 16. 16 plus 7 is 23. So if you add 2, 3, do 0 for this, you will get 2400. So interest at the end of 30 years equal to rupees 2400. Okay, I hope you can understand this problem. So let me go to the last example of this session. In a flower bed, there are 23 rose plants in the first row, 21 in the second, 19 in the third, and so on. There are 5 rose plants in the last row. How many rows are there in the flower bed? So they have arranged the rows like this and kept the rose flower in each row. So in the first row, they have 23 rose plants. In the second row, they have 21. In the third, they have 19. And so many rows are there. In the last one, they have kept 5 rose plants. We have to find how many rows are there. So that is, we have to find what is n. So here A is equal to 23 and we have to check whether it is a AP or not. So D is equal to second term minus first term, which is minus 2, and third term minus second term, which is also minus 2. So this forms an AP. Then we can use the formula AN equal to A plus N minus 1 into D. What they are asking? How many rows are there? They are asking for N. So here we have the last term. So L is equal to 5. So L is equal to A plus N minus 1 into D means 5 is equal to A is 23 plus N minus 1 into D is minus 2. So keeping 5 here, 23. So here negative sign is there, minus 2 into N into plus. So plus into minus is minus 2N. So plus into minus, it is minus. Minus into minus, it is plus. So it is plus 2. So 23 plus 2 is 25 minus 2N. So minus 2N, I am taking it to left hand side. So it will become plus 2N. Here 25 is there. I am taking 5 to the right hand side. So it will become negative. Plus 5 will become negative. So it is equal to 20. 2N equal to 20. Then N is equal to 20 by 2, which is 10. So it means there are 10 rows in the flower bed. Okay, I hope you can understand all the problems. If you have any doubts, you can comment me. Also, if you like this video, just share, like and support me with your subscribe button. Okay, thank you for your support.